Alright, here's more on the net change theorem. Alright. More vocabulary. So net change can be also described as displacement. Okay. Displacement. And then we can talk about total distance traveled. They're two different things. Displacement is what is the net change. Okay, so if I start at point A and I end up at point B, how far apart are those 2 points? That would be displacement. Total distance travel would be, so let's say we have a rate that makes this kind of path, right? That you go away from A, but then you come back a little bit to A, and then you go back towards B again. So there is this area where it travels three times, right? So total distance would be how long is that, plus how long is that, plus how long is that. So you got to add all 3 of these up. While displacement is just from A to B. Okay, and that's it. Alright, that's the net change idea. Alright, number 7. Consider a particle moving along the x-axis where x of t is blah, 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 blah. Complete the table below that gives the particle's position at each of the 5 time intervals. Okay, so just plug in those numbers. Alright, we just plug it in those numbers. So I'll plug in 0 into that, and I get -2. Plug 1 into that, and I get what? 1 minus 6 plus 9. Okay. Time to resort to the calculator. So all you were doing is plugging it in. So I want to plug that into the calculator. X cubed minus 6x squared plus 9x minus 2. Alright, plugging it in. And that's a nice little table. It's going through 5, so I'm going to do a table setup. And I'm going to start at 0. And my delta table is just 1. Alright, that's it. And then go to the table. Alright, so 0, -2. So I just copy that now. Alright, so all I'm doing is copying these numbers. So 0, it's -2. At 1, it's 2. Then 0. 3 is -2. 4 is 2. And 5 is 18. Alright. Find a total distance the particle travels in 5 units of time. Total distance travel. So total distance travel in those 5 units. So 0 to 5. And total distance is, you want the absolute value of the derivative. So the derivative is 3t squared minus 12t plus 9. Right? So you're not going to actually use the function. You want the derivative. That would be the total distance. So, second quick. And I'm using the calculator again. So it is, now for window, I want number 4. Right? I'm getting number 4. That's numerical integration. And I'm going from 0 to 5. And I want absolute value. To get absolute value, you go to math, and you want number. It's a number thing, right? ABS is absolute value, and brings that up. And I'm going to put that in there. 3x squared minus 12x plus 9. And put it in here. Where's the dx? There's the x. X, enter. And it has to think a long time. Ooh, that doesn't happen often, right? Where the calculator has to think. And it's 28. So 28. Why is there an absolute value in the expression? Because the particle goes back and forth. The particle moves left and right on the interval. So we apply the absolute values to compensate for sign changes. Find the total displacement of the particle. Displacement. Displacement is different. We're going to remove that absolute value. And bad news is I don't know how to remove that absolute value. So I'm just going to type it over. So 4, 0, 5, 3x squared, 3x squared, 3x squared. Not, is it squared? Oh, yeah, it is. All right, minus 12x plus 9. Okay. Remember, we're doing the derivative. We're not using the original function. So this is the derivative. Oops, I forgot to put in the x. So it's 20. So total displacement is 20. All right. So total displacement is 0 to 5 of 3t squared minus 12t plus 9 equals 20. Wow, that's horrible. All right. 132 to 0, 133. Let's see. All right. That's it. Sorry.